guys tell me again if you have any problems. Now, to find out if two things are inverses of each other, you have a bunch of ways. You could take this and write your matrix, and it will look just like this one. It will come out like this one. You could do this times a to the 1. Well, you had to find out if both of these were inverses. If you're going to multiply these, remember, you have to multiply those both ways. They have to be A times B and B times A. Has to give you the identity matrix. This is called your identity matrix. It has to go both ways. You have to show that this is commutative property. So again, you do your identity matrix. This one I just asked, what is the inverse? Just put it in a to the negative 1. Flip it back to a fraction. It takes less room because it's going to say 0.33333. You don't want to round any of your decimals. So this looks like it went pretty well for you guys. This has to be a square, first of all. Even a square matrix can be singular. It doesn't have to be invertible. It doesn't have to have an inverse.
If it's 1, 1 still square?
1,
1, 1.
so it has one number. You could have a matrix 1, 1, and then it could maybe be invertible. Yeah. We okay with this? Finding inverses? Okay. You're going to have to know how to do this. If I ask you to solve an equation using an inverse, you're going to have to know that you're separating out your coefficients, your constant. Okay? You're going to have to take your inverse of this guy. I drew it out, but you don't have to do that. In your calculator, you can say a to the negative 1 times b, and it will give you that value of your x's. You don't have to show me. I printed it out so you could see it. But we're going to take the inverse of this times its constant to equal this. Now, technically, a times your x1 will, a times your b1 will equal your original one. No, a times your x times your a1 will equal your b1. Again, if it doesn't have an inverse, your calculator tells you singular. Sometimes it says wrong dimension, a mismatch. Sometimes it says singular matrix, which means your matrix doesn't have an inverse. And then you don't know that till you go to try it. And we just say no inverse. Again, a to the negative 1 times b. This is what I want you to show me. Do you have to draw out your inverse? No, I don't need to see it drawn out. But I do need to see the statement, guys. I do need to see that you solved this. I do need to see this one and this one. This is a 4 by 4, so that will work. When a 4 by 4 is multiplied by a 4 by 1, we say yup, and our answer will be a 4 by 1, which is this guy right here. And remember, sometimes you see them as subscripts, not as x, y, z, w. You see them as x1, y1, x2, x1, sub 1, x sub 2, x sub 3. Sometimes they subscript rather than use a variable. A lot of colleges use a subscript. So are we okay with this? Pretty easy part for inverses. So if you're doing a matrix, it looks like this. And we put your numbers in here. When we do a determinant, we use straight bars, like this. These bars tell me I want a determinant of my matrix. I still put it in as a matrix, but when I go to calc, I do a DET. I do a determinant. Now, what we ask you to do is to be able to do one determinant, a 2 by 2. Again, it has to be square. It has to be a square. And all we ask you to solve by hand is a 2 by 2. The rest you're going to do in your calculator. Now, do you remember way back, probably like 7th grade, 8th grade, when you had a ratio? I don't know. Remember when you had a ratio and you cross-multiplied this. Do you remember anybody calling them the means and the extremes? No.
Yeah.
They usually called one the means equal the extremes. So the product of one was equal to the product of the other, a means and an extremes. When we do determinants, we kind of do that. We just say, go up like this. It has to go in the right direction. It has to go up like this. So not down, because you're going to look up here. You're going to multiply these two. Minus, multiply these two. So that's your rule for doing this. You're multiplying up and you're subtracting them. So when I subtract this, my determinant would be 7. It's a number that we find for a matrix, and we use the determinant for many things. If you put this in your calculator, of course, you put your matrix in. Whoops. You put your matrix in. And again, it has to be a square. So, okay, I'm going to quit. And now watch. When you go to matrix and you go to math, it's sitting at determinant. Probably because this is the one most used. I click on A, and I say, whoops, I must have put my matrix in wrong.
Supposed to equal 7, right?
Yeah, I missed my negative. It's supposed to equal 7. So when you do this, guys, it will give you 7. So a little way to cheat, if you didn't do it in the right order and you checked it in your calculator, you would see that it wasn't the right thing to do, right? So you'd go back and say, oops, maybe I forgot to subtract. Maybe I added by accident.
So we have to write it out first. We can't do it just on the calculator and do it.
Well, I have to see your work, right? So there's no saying that
And
you
you just
just
have to see the X.
I have to see your product and your minus. But say, for instance, you forgot and you did your product be added. When you put it in, check it on your calculator, it won't work, right? So you're looking at 1, but you're looking at 4 minus, say it was 4 minus 3. And you added them, you got 7, but your calculator got 1. So you'd say, oops, I was supposed to subtract them. And just put a subtract sign. Cool, no. But just so that you know where this is coming from. More importantly, I just want you to know where it's coming from. Now, again, you can use any matrix, any square matrix, and find its determinant in your calculator. So you all think you can find that? Good. Now, one of the things we use your matrix for, and we just talked about, and you said you'd have to use your distance formula. So if I gave you 3 vertices, you'd have to plot them, use your distance formula, use your fact that you need to make a perpendicular line to the base if you didn't have one, make the distance for that. But we have a nice little formula using your determinant to find the area of a triangle given 3 vertices, coordinates. Now notice this says plus or minus, because a determinant can be negative, but an area cannot. So if your determinant comes out negative, then you'll use the negative part of that because your area needs to be positive. So we're going to try one, which makes it a little bit easier to explain how this works. So we're going to take these points. If I graph them, for instance, if I graph them, here's my 1, 0. Here's my 2, 2. Here's my 4, 3. Here's my triangle. Would be a nightmare. I'd have to take the distance. I'd have to drop a perpendicular. I'd have to find that distance, and I'd have to do all this work. Instead, we're making a matrix. Put your coordinates like this. Just list them down. And we're going to take the determinant of this. Now, don't I need a square to make a determinant? But I don't have a square. So what we do is we fill this last column with 1s. It has to be 1s. And now we find the determinant of this. So throw it in your calculator and find me the determinant. Most important thing is filling this last column. It has to be a square. So find me your determinant. -3? You sure?
Mm-hmm.
Yeah.
Okay. So your determinant is -3. Now, here's my area formula. It almost looks like plus or minus base 1/2 base times height. But here's my determinant. Now, my area always has to be positive. The areas can't be negative. So because my determinant is negative, I need to use the negative in front of here. I need my area to be positive. So I multiply those two, and my area is 3/2. So now I didn't have to find this distance, drop a perpendicular line, find that distance, multiply them, take 1/2 of that. I can just use this formula. If your determinant comes out positive, then you use the +3. Because your area always needs to be positive. So that plus or minus is there to make your area remain positive. Make sense? The hardest part is making that a square. You got to fill the right side with ones. Okay, now, we have a rule called Kramer's rule. And Kramer's rule uses the determinant to also solve the systems of equations. So Kramer's rule says, if you find the determinant of your whole problem, your whole thing with your coefficients, and then you replace that last line, that last row, that last column, you should be able to solve for your x and your y and use your determinant to figure this out. So we are going to take, I can't fix it all in one, so we're going to have to do this here. So we're going to take out your coefficients, like this. We're going to put bars here because we're going to find the determinant. And we're going to put your solution right here. Okay, so now, the first thing I want you to do is to find the determinant of this whole thing. -14. Now, watch really closely first before you start writing, and then I'll go over it again so that you can write it. To solve, this is my x, this is my y. To solve for my x, I'm going to take this solution and replace my x row right here. So my x row is going to be replaced like this. The rest is going to stay exactly the same. This is to solve for x. Because x first and then y. So I just take my x column out and I replace it with my solution one, with my constant one. And I find the determinant for this guy. Now be careful. You can, the first time through, you can write over what you had. The second time through, and I'll show you in a second, you might not want to write over it. So find me the determinant for this guy. You can do this by hand as well. -50 minus -22. So this becomes a positive, and this becomes what? 28? -28. You can do them by hand as well. So now, we take the determinant for x, over the big determinant to find x. So we say negative 28 over negative 14. So x is equal to 2. Okay? Yeah? Well, but that's the concept. So now we replace this back to normal, and we take this solution and replace the y. So we put this in for y. The rest of it has to go back to normal. That's why you might want to re-put this one in rather than try to write over the one you have. Because if you go back to this one, you got to get this column out of here, the 10 and the 11. It's got to go back to the 4 and the 3. So now I only want to replace my y. So find me the determinant for y.
14.
Okay? So to find y, we take the determinant of y over the big determinant. So 14 over negative 14, and what is y equal to? Negative 1. So here's my solution. If I had 3 variables there, I would do the third one and find z. And we'll do one in a second. But all we're doing is separating your coefficients and your constant, finding the determinant of the coefficients first. Then we're replacing each row with your solution, with your constant. Finding that determinant and making a little ratio here. And that's it. Either that or just make sure you give me an x equals and a y equals somewhere. So let's try another one. Okay? So, first step, do you have this one? So first step is separate it, coefficients, constant, and make a matrix bar. I'll make a determinant bar. And put your constants over here. So find me the determinant of this big one. Got to get the determinant? Good. All right, now, first time through, we're going to take this and we're going to replace the x row. Just the x. And find me the determinant of x. Negative 4, 10. Good. So you're going to take the determinant of x to find x over the big determinant. So negative 410 over negative 82.
5.
There you go. X is equal to 5. Okay. Second time through, we're going back to our original one. We're taking this, we're replacing the y row. You've got to just make sure that you reset this back to the normal matrix. That's why after the first one, I would just re-enter the whole thing. Because if you keep copying over the one before, you might not replace the original one. So find me the determinant of y. You got it. So we're going to take your determinant of y over the big one.
So y equals 8.
Okay, so y equals 8. You got it. And now the last one we're going to do is the z. We're going to take this guy and replace the z. And bring the other two back to where they were. And find me the determinant of z. Determinant of z over the big determinant. And z is equal to -2. Now you just found all your answers. There's your solutions. If you want to string them out, x, y, z, that's fine too. You want to leave them to me so I can see what the answers are? That's fine too. A lot of colleges, if you go to college and they do matrix work, they always use Kramer's rule. So not bad, right? Questions?